Okay, we've done limit problems before. This chapter we're going to think about how to evaluate the limit as x goes to infinity or negative infinity. The solution that is usually given is a very formal one. The formal way to solve this question is you divide by the highest power of the denominator. So x squared is the highest power. So you divide everything by x squared, both top and bottom. So if you have 3x squared, you divide by x squared minus x over x squared plus 5 over x squared. Then x squared over x squared minus 5x over x squared plus 2 over x squared. So these two are the same because these two are algebraically equivalent. Right? Evaluating this for any x is same as evaluating this function for x. These are algebraically equivalent because in a fraction you're allowed to divide by anything both top and bottom as long as you're dividing by the same thing. I'm dividing the top and bottom by both x squared. Those are the same thing. So these are algebraically the same thing. They're the exact same functions. Okay. Now let's try to simplify this. 3x squared over x squared, that's 3. I can simplify this as 1 over x plus 5 over x squared. And x squared over x squared is 1. 5 over x, 2 over x squared. And again, since all I did was simplify, these two will be exactly the same functions. For example, if I evaluate this for x equals to 1,000,000, that will be same as evaluating this function for x equals to 1,000,000. There's no difference between the two. Okay, now let's think about what happens to 1 over x as x goes to infinity. So if you take 1 and divide by 1,000, that's 0.001. If you take 1 and divide by 1,000,000, that's like 0.5 zeros and then 1. And as you can see, if you're dividing 1 by a very, very large number, what happens to this result? The value becomes closer and closer to? Zero. Right? The same thing here. If you have any finite number and you're trying to divide that among many, many people, right? If you have only $5 and you have to distribute equally to 1,000,000 people, it's impossible. Like less than a cent, right? So it quickly goes to 0. So all these become 0 when you divide by infinity. So after all that, you're just left with So these values all become zeros, and if you think about what happens after you put them to 0, you just have 3 over 1, which is just 3. It's exactly equal to 3. So that's the formal way of solving. This is logical and very clean. However, there's an intuitive way of solving this. And let me try to explain the second method. And I like this better because not only it's quicker, it helps us with our intuition of what's going on. Okay. So let's think of it like this. X is sent to infinity means x is a very, very large number. Okay? It becomes a large number. So think about the following case. What's x squared if x is 1,000,000? What's 1,000,000 times 1,000,000? A trillion, right? 1,000,000 times 1,000,000 is a trillion. So 1,000,000 squared is a trillion. You're looking at the following value. You have 3 trillion minus 1,000,000 and plus 5. Okay. I mean, imagine this was money. Let's say you had $3 trillion. Of course not, you don't have it, but if you had $3 trillion and doctor asked, can you give me $1,000,000? You would say, sure, why not? Because 3 trillion is so much, million is not anything. So you just give $1 million to Dr. Arnold without any problem, right? And then $5, that's gaining $5 wouldn't matter anything to you. So in other words, when you are dealing with the trillions, even the millions don't do anything to you. Okay? So you can basically think like, oh, these two guys, 3x squared and x squared, these are the playas, right? And the other guys are nothing. They don't like add to anything. So we just ignore them. Okay? So ignore the non-important people. Just think about what the big guys are doing. Okay? And then once you ignore them, then you can say, oh, if this is 3x squared divided by x squared, so it's like 3. So that's another way to think about this answer. Now, let me, I don't want to erase this, so let me just write down a second question, very similar. Because I want to show you what happens if we apply the same kind of reasoning to the following question. Okay? So for example 2, I mean, they look very similar. What's the difference? What's different from this question and that question? The exponent, right? This is cubed, whereas that was squared, right? Other than that, I wrote the exact same questions, right? Okay. Now, for this question, think about what happens if you only allow the big guys to play. 3x cubed minus x plus 5, x squared minus 5x plus 2. And we say, well, if x is something really large, these are just small compared to x squared and x cubed. So let's only let the big guys play against each other and see who wins, right? Then we have x cubed divided by x squared, which simplifies into what?
3. 3x.
It's actually 3x, it's not 3, right? There's one more x on the top. So it's 3x, and you're sending x to infinity. What would this give you? It will be positive infinity, right? Now you can do the same exact kind of solution like this first type, dividing by x squared top and bottom. If you do that, what you're going to get is this one here. If this was x cubed instead, you're going to get 3x. So that at the end of the day, you're going to get 3x over 1 with the limit x going to infinity, so you get the same answer. So whatever we solve with the second method, you can solve it with the first method. It's just slightly longer, and it's less intuitive what's going on. So I would like to use this as my main approach to the limits. Now, third one I want to do is, what if I didn't have 3x squared? Let's say this is example 3. What would happen to this limit? Again, if you think about these as small compared to the highest terms, you can just ignore the rest and think about the competition between negative x and x squared, right? And that's limit x going to infinity of negative 1 over x, and x is sent to infinity, so what's that? You're dividing a finite value by infinity, so you get 0. So you can actually come up with some general formula, like if the order of the top and the order of the bottom match, then the limit is the ratio between the two coefficients. the order of the bottom is bigger than the top, then it will be 0. If the top is bigger than the bottom, then it will be, the answer could be infinity or negative infinity. These are the things that you may have learned in pre-calculus, but if you try to solve in this manner, you don't have to memorize those separately. It's just very natural if you take this approach.